Okay, let's look at question 5 first. Where it says that the point P23 lies on the line 3x minus 4y plus 6 equals to 0. And then after that, this line actually intersects another line. They intersect at point Q. So we want to find the length of the line segment PQ. Okay? Just to help yourself in understanding the question better for coordinate geometry, what we should do is to actually draw a diagram to facilitate the understanding. The diagram need not be accurate. Okay? So even if you draw it wrongly for the gradient and all that, it is fine because we just want to understand the question. Alright? So what we see is that there is a line, okay, then after that there is a point 2, 3. So maybe draw some axis. Okay, in this case, actually maybe something like that for 3x minus 4y plus 6 equals to 0, 2, 3. And then after that there is another one that is 2x plus 2x plus y plus 4. So let's say something like that. And then they intersect at the point Q. Okay, and this is P. So we want to find out what is the distance PQ. How could we find the, so now that I've drawn the diagram, first step we need to find out what's the coordinates of Q. Because if we don't have the coordinates of Q, then we will not be able to determine the length. Because the length formula requires the coordinates of both points P and Q. Agree? So how should we go about finding the coordinate of Q? What should we do? Who asked about question 5? Yes. Bernice? What do you think? How should we find the coordinates of Q? We are looking at the intersection of two lines and the intersection point is Q. How does that graphical idea translate it into algebra? What do we know about simultaneous equation? Simultaneous equation, we got elimination method, we have substitution method, and then we also have our graphical method, right? So, sub the coordinate 2, 3 into the equation. I want to find Q, find the coordinates of Q. We're looking at the intersection point. So whenever we're looking for intersection point of two different lines with two different equations, what we should do is to, Chloe, what do you think? Solve by? Sorry? Yes, simultaneous. Okay? So we should solve simultaneously. Alright, so maybe from equation 2, we would have this. And then sub 3 into 1. So we found the x equals to -2 and then the y would be -8. Sorry, 0 plus 4 here. Okay, so therefore the coordinates of Q will be -2 and 0. Right, so now that we have the coordinates of Q already, finding the length of PQ will just be using the formula where we take square root the difference of the x coordinate plus then square, then plus the difference in the y coordinate, and I'll leave you to find that value. Okay? Understand? given 3 points, no numbers involved, just A, B, and C, and then after that, they are collinear. We want to show that they are collinear. Sorry. Okay, so what are the 2 criteria in order to prove that they are collinear? What did we cover? So we got these 3 points, right? To show that they are collinear, what are the 2 criteria? What's the 2 criteria? Yes. Parallel lines and what else? Prove that they are parallel and common point. So, first thing is to know what is the gradient in order to actually conclude that they are parallel, right? So, you find the gradient. Did they give any labelling for the points? Okay, so maybe let me just put this as A, B, and C. Gradient of AB will be equals to B plus C minus A plus C over A minus B. So we will get B minus A over A minus B. Okay? Can this be simplified further? B minus A over A minus B. Can we simplify this fraction further? Yes or no? Yes, Joanne, how do I simplify it further?
Take out the derivative sign, so it becomes negative.
Okay. In the numerator? Very good. Okay. It just so happens that this can be simplified. Alright, no need to leave it as an algebraic expression, algebraic fraction. Okay, so we get -1. Alright? Then next we find out what is the gradient of the other 2 points. So let's say if I were to choose AC, for example. So we will get A minus C. Okay, we see that we have C minus A over A minus C. Okay, so likely that maybe you are stuck with these 2 when you find the gradient. Okay, then after you realize, how do I explain that they are actually equal? Right, the reason is because of the simplification process. Okay, not realizing that it can be further simplified, where you can get this to be equals to -1. So now that we see the gradients are actually the same, we can conclude that they are parallel. And the common point in this question in my working is actually point A. So we say since A, B, and AC are parallel, and A is the common point, then A, B, and C are collinear. Okay, we got PQRS as 4 points. We want to find the possible values of K such that PQ is parallel to RS. So these are all the information given in the question. Okay, we shall look at finding the gradient of PQ and also the gradient of RS, and then equate them because they are parallel. Okay, then after that we can So gradient PQ will be 3k minus k minus 2 over k squared minus k. Okay, and that will leave us as 2k plus 2 over k squared minus k. Then we find the gradient of RS. That would be k plus 2 minus 1 over k minus 1. And we get k plus 1 over k minus 1. Okay? Then next, we will equate them. And we cross multiply. From here, what next? What should we do next? Are you able to reach up to this step at least? Okay, then what next? Zhenquan, what next? Sorry, expand, okay. Expand and then you're going to blend yourself with a cubic equation. 2k squared minus 2k plus 2k minus 2. Equals to k cubed minus k squared plus k squared minus k. And we arrive at this. Then how? How? Have we learned how to solve cubic equations? Yes. So how do we solve a cubic equation? How do I solve a cubic equation? Sorry? Okay, we use our calculator. And then after we press the coefficient to find out what is a suitable factor, right? Sorry, I forgot to bring up my calculator. What do I get? What are some suitable numbers of k that I can...
1, negative 1, 2.
Sorry?
1, negative 1,
1, negative 1 and 2. Okay, so we use when k equals to 1. Equals to 0, therefore k minus 1 is a factor. completely, I will have k minus 1, k minus 2, and k plus 1 as the factors, which is consistent with the values that you have from your calculator. Okay, so therefore, when we want to solve the cubic equation, we find that k will be equals to 1, or k equals to 2, or k equals to negative 1. Alright? They did not specify any conditions for k, so nothing to reject, all answers are acceptable. Any questions? Right? Yeah, is there an issue?
Okay, right.
You do the gradient for... Hang on, okay, good point. So k equals to 1 should not be an answer. Right? Okay? I agree. So we should get k equals to 2 or k equals to negative 1 only. Right? Any questions? Otherwise, submit your homework to the front. A formula list that I thought might be helpful. I printed it out in colored paper so that you can easily find it. If you don't like the color, please sort amongst yourself. Formula list. Okay, we will do some arithmetic. Okay, prepare a scissors if you have. If you don't, you can take a ruler. Otherwise, you can go back home and figure it out yourself. No, I didn't ask you to tear it in half. So how to actually cut it? Alright. I know that what I printed for you may not actually be a very clear thing. Okay. But generally you cut out the borders. Okay. And then after that you cut through in between the page 1 certs and indices and also page 8 integration. Right? You should cut in between integration and certs and indices. Alright? And then after that, above certs and indices and integration, you also cut through that as well. Okay? So if you can, you may want to do it now. You can go and cut the borders later on. Once you have created the flaps, you go along all the other straight lines. When you cut, you fold these two flaps inwards. Okay? Then after that, you fold outwards like that. And then after that, just clump it together. And it will be a book that runs continuously from page 1 all the way to 8 on integration. Oops, why is it missing? You understand? Let me do it again. After you cut in between certs and integration, you fold in between, cover it up like that. Okay, fold it like this, and then after that you should close up like that. Alternate. Okay. If you don't have anything to use to cut now, or you want to perfect it at home, there is a video already on my YouTube channel that I've done a year ago. You can go and check that out. I think I call the video A-Math Formula Booklet, something like that. Okay? The reason why I'm giving this to you now, usually I give it at my Set 4, when my students at Set 4. Okay, because I find that maybe some of you are already struggling with logarithm laws. So I have over here the logarithm laws already for you to easily access. Okay, you may keep it inside your pencil case. Oops. You may keep it in your pencil case, but just remember that during exam, when you're taking exam or test, take it out. That's the reason why I put it as colored paper, so that you do not forget. Okay. However, after I have printed it out on colored paper for you, I realized that my PDF version that I printed had an issue, okay, in the formatting. So, unfortunately, I need you to just correct. I believe it's certs and indices. Okay, in certs and indices, right? I think could I see your font indices? Okay, what you see in yours is that there's an arrow sign over here, arrow sign over here, arrow sign over here. Okay, this actually should be multiplication. Alright, I hope that you're aware these are all your certs. Okay, should have been multiplication. Alright? If you remember your surds and indices, okay, this should have been multiplication signs. I'm sorry, why is this so fast? Okay, so this should be multiplication signs. Okay, and this one over here, there's this box. I actually meant it to be an arrow sign like that. Okay, because we know that when we have the exponents, when we compare exponents of two indices that are of same base, we can equate the exponents to be x equals to 1. Okay? So progressively throughout your A maths journey, I hope that this will be helpful. If you lose it, please find it out yourself on my website. Okay, I'll upload it onto Google Classroom as well for you to print it yourself. Okay? It should really be a book like that. Okay? Okay, let's keep this aside. Let's get back to our EMAT 7.2. We were looking at parallel lines. Then after that, other than parallel lines having equal gradients, I have also told you before already on how to, or rather I introduced to you on how to actually find the equation of a straight line. Okay, and I've shared with you a different method of finding the equation of a straight line. So parallel lines, equal gradients, and then when it comes to equation of a straight line, I've shared with you a different way of finding it. So today our discussion will be on perpendicular lines and understanding how does the gradient of perpendicular lines actually relate to each other. So when it comes to perpendicular lines, right? Okay, so if I have two straight lines that are of equations, for example, y equals to m1x plus c1. Okay, these are just some numbers. Okay, and another straight line that is y equals to m2x plus c2. Okay, for perpendicular lines, the gradient m1 and m2, when I multiply them together, it will be equals to -1. Okay, that is the property about perpendicular lines and how that relates to the gradient. Okay, another way that we can see it is also that I can divide the m2 to the right side, and I see that m1 is equals to -1 over m2. Okay. Equals to -1 over m2. Okay, in mathematical language, we call this, we say that m1 is the negative reciprocal of m2. Okay, so we use the term negative reciprocal. Right? Negative because there is this negative sign over here. Reciprocal because it is 1 over something. So that sometimes appear in your books. Okay? In case you're wondering what it means. we want to find the equation of line through a negative 2, 4 and perpendicular to 3x plus y minus 1. Okay, so if you don't understand it in words, alright, you may want to draw a diagram. So what it simply means is that there is a line. You don't really need to care about how this, whether this line is upward sloping or downward sloping. If you can see it fast enough, it's actually a negative gradient, okay, and it's downward sloping. But that really doesn't matter. It's just for you to understand the question. So when you have the line already, okay, we will put in the point A negative 2, 4. So negative 2, 4 may be somewhere here. Okay, maybe let me adjust this one. Right? So we want the new line to actually be going through this point and perpendicular to 3x plus y minus 1 equals to 0. Okay, perpendicular. So how we understand this is that the line will most likely look something like that. So this straight line that I've drawn is the line that we want. Okay? So because the question says that it is perpendicular, we need to understand what is the gradient of the first equation. And we make y the subject, okay, such that we have it equals to negative 3x plus 1, and we find that the gradient is actually equals to negative 3. So the gradient of the required line will be the negative reciprocal, so negative 1 over negative 3. Okay, so you may do it in this manner. Otherwise, you can think about it as negative 3 times m2 equals to negative 1. m2 equals to negative 1 divided by negative 3. So it's the same thing. Okay? So now that we have gotten the gradient, this simplifies to be 1 over 3 anyway. Now that we have the gradient of the required line already, we can proceed to find the equation of the straight line, which will be y minus y1. Okay, so if I were to make use of this formula, this equation, what I'll do is I make use of the point, because this point is the one that passes through what we want. So y minus 4 equals to 1 over 3 x minus negative 2. Because the point is negative 2, 4. This equation for the straight line. If question wants it to be integer coefficients, you will get this. So either one is acceptable in this question unless they ask for integer coefficients. Any questions? Is a continuation from part 1. Given that they intersect, we want to find the coordinates of n. So the two lines that we were looking at was this one and y equals to 1/3 x plus 4 and 2 over 3. So since they intersect, we solve it simultaneously. Okay, I multiply by 3 across to make it all integers. And we find that x is equals to negative 11 over 10. So we conclude that n will be the point negative 1 and 1 over 10 and 4 and 3 over 10. Next, part 3, we want to hence find the shortest distance from A to the line. So, just now actually if you were to have the diagram, what's the diagram just now? Okay, so these are all the information, right, that we are marking into the diagram that we had earlier. Okay, so we want the shortest distance from A to the straight line. Okay, so what we have covered in E-maths, right, is that the shortest distance is always a perpendicular distance. So actually what we want to find is this length here. And since I know the coordinates of A and I already know the coordinates of N, okay, we can find out what is the shortest distance. By using the length formula. And we get the answer to be 0.949 units. Rounded to 3SF. because I noticed that that example doesn't actually require any use of perpendicular lines. So I have no idea why the publisher put that question there. Okay, so we'll find that example 5 is the more meaningful question to go through. Okay, so in example 5, right, we are given a trapezium. Okay, then after they gave you all the information about this trapezium, right, and in part I we want to find the equation of AB. Okay, so we understand that AB is actually parallel to CD, alright, and we have the point for B, okay, which is 6 and 15, right? So what we're missing over here is the gradient. So how do I determine the gradient of this line AB? How will I be able to determine it? Kaylee, what do you think? Yep. AB is parallel to CD. How do I find the gradient of AB? What about the rest? Yes, Rina. Huh? Same gradient, thank you very much. Okay, so the gradient of AB will be the same gradient as CD. So we find the gradient of CD by making use of the equation of the line. And that will be equals to 2. So now that we have the gradient already, and we have that point, we get this. We have y equals 2x plus 3. Then after that, in part 2, I need to find the equation of BC. How do I find the equation of BC then? Ling Hui, what do you think? BC is perpendicular to AB, also perpendicular to CD. So to find the equation of BC, we need the gradient. What did we say about perpendicular lines? Perpendicular lines have what kind of gradient? Is anybody even listening in my class? Yes, Joseph.
Take the gradient of AB and divide by the -1.
Okay, we get the gradient of AB. Okay, then divide that by -1. Actually, it's the other way around. We take -1 divided by the gradient. Okay, so gradient of AB was actually 2. So gradient of BC will be -1/2, because it will be -1 divided by the other line's gradient, since they are perpendicular. Then after that, the equation of BC is actually y minus, we take the point B because the point B lies on the line BC as well. And we have y equals to -12 x plus 18. Then in part 3, we want to find the coordinates of A and C. So let me just put in the information that we already got. So AB has the equation y equals to 2x plus 3. And BC has the equation y equals to -12 x plus 18. Right? And in part 3, I want to find out the coordinates of this. Okay? A is on the y-axis. Alright? So I believe it might be easier for us to find the coordinates of A first. So how should I find the coordinates of A? Yes.
This A is on the y-axis, the x, then the y-intercept is 3, so A is 3.
Very good, good thinking. Okay, we got this equation of the straight line y equals 2x plus 3. Since this is the y-intercept of this straight line, actually we can easily see that the y value here will be 3. Okay, that's one way to see it. If you didn't realize that, you can do it through the usual way, where we let x to be equals to 0 into the equation of the straight line AB, and we find that y is 3. So the coordinates of A will be 0, 3. Then after that, when you want to find the coordinates of C, how do we find the coordinates of C? Answer, what do you think? How should I find the coordinates of C? Yep. We have the equation of BC and I have the equation of CD. What were the coordinates of CB? Do you know? It is the intersection point of two lines. So when we want to find intersection point, what must we do? Yes? I can't hear you, I can't read your name as well. But is the mouth even open? I don't know. Simultaneous, thank you. Okay? So, we will solve things simultaneously. We solve equation 2 into equation 1. complete it. But for part 4, right, I will not explain part 4. You may read it yourself. The working is in your textbook. Okay, the reason why I don't want to go through part 4 is because actually when we move into chapter 7.4, there is another formula that I will introduce to you in terms of finding the area of a quadrilateral easily by using the coordinates. Okay, so I don't see much purpose in doing part 4. Right? So next week when I have the online lessons with you, okay, I will only have 2 lessons. Right? Yep. Okay, I will finish up chapter 7.2 on the lesson on Monday. Okay, then after that on Thursday I may actually go into 7.3. I will see how it goes. Okay, how long the video will turn out to be for the remaining of 7.2. Otherwise, I may actually combine a bit of 7.3 into it. Alright? Any questions? Okay, then that's all for A-Maths today. It has to be a certain direction. It must be in the anti-clockwise direction. It cannot be clockwise. Oh yeah, sorry. Before you all go for another one, I want to return your exercise 4.2 homework.